I have a name, I came from a company, and we'll talk about Git. Let's move on. We'll cover a few topics that you all heard about, but from my experience, not all of us have used them. So yeah, that's why I'm talking about it, because I have met people that worked in IT for years, and they didn't get a chance to play around with these. For many of us, Git is like which is familiar, this small creature that follows us around and helps us with day-to-day tasks. It remembers your work, it keeps it safe, it helps you coordinate your work with others, and it helps you remember what you did wrong 3 days ago. And that's cute, but depending on what projects you're working with, that might be all of it for you. And there's so much more. You might never discover the final form of this creature and its true power. But sometimes you change your environment, you change your company, your team, and you land in a place where Git is very valued, cherished, and nurtured, and there you meet Bill. Bill introduces you to the team, to their practices, and helps you learn all the tips and tricks and true powers of your tools, including Git. For example, rebase is something that we do when we finish a pull request, right? That's what you thought. But you enter the team, and your pull requests are getting rejected. Nobody wants to review them because they are messy, because you can clean them up. And you just say, oh, come on. You either keep the history as it is, or you click squash and rebase at the end of PR, right? And Bill comes to you and says, not really. You can do more, and rebase can help you with that. For example, this is what you already know, right? Rebase does, it takes a branch, it moves it to another place, and keep in mind, these are not the same commits, it creates new ones. Okay? Yeah. If you started a branch on a branch, but they're not really dependent, rebase can help you separate them. You can rebase onto and move your independent branch directly on main. And that's fine. And if you need to do anything else with your history, rebase can also help you. Another example, you worked for a full day, you got carried away, and you implemented 2 features in one branch, and again, nobody on the team wants to review that, and they say, clean it up, create 2 pull requests, and then we'll talk. And you're already like, okay, now I reset back to the beginning, but not with the hard reset. I keep the changes, but I uncommit them with a reset, and then I manually mark every change with like add chunks, something, something. But it will take time, and it's error-prone, and I don't really want to do that. And again, Bill comes to you and says, you can do better. Interactive rebase will help you with that because, take a look, most of your history is already separated. It's clear that here you implemented one feature, here you implemented the other, and there was only one place where you made configuration changes, just a few lines where they are mixed up, right? So you can do manual changes only in one commit and separate the rest using rebase, just like that. And that's simple, that's easy. Git always helps us with very comprehensive command line output, right? You enter the interactive rebase, and you have the full information on what you can and cannot do in place. You can pick, you can drop, you can fix up, you can edit, and you can squash if there are changes that are connected and should really have been an amend from the start. And Bill shows you how you separate the branches, because you already know, wait, what? No. You already know that this is one feature, again and again, this is a single feature, and you only need this to have a custom change, And for the other feature, you have well-known commits that you want to pick and not the others. So for one branch, you do that. You start with your cool idea, and there you create a new branch for the separate feature. Then you rebase, and you pick, you pick, you pick, you drop the rest, and you only edit this one commit. Git will jump out of its process, let you edit, let you add, let you commit here, and do automatically all the rest for you. So that's cool. Then you do the same for the other branch. It will be exactly the same but reversed. You create a bar branch, you pick, you pick, you pick, you drop the rest, and you edit this one. And what you end up with is that. Because we created new branches, the old one didn't disappear. Because remember, rebase doesn't destroy anything. It creates new commits. It creates copies of them. But the old ones are in place as long as you reference them or as long as garbage collector doesn't clean them up. Once you got some practice, your rebases were cool and clean, and your PRs got accepted over and over, Bill decided that it's time. You can do more. Come here. These are our old projects, our old our master project that we separated into microservices. So what happened on the way is that we decided that we wanted to separate the projects and their builds to develop them separately, but at the same time we had dependencies that we didn't want to build separately, so our colleague there, Bruno, advertised submodules as a solution. He's a big Git fan, and he likes to have Git in Git, in Git, in Git, and he claims that it's simple, it works all the time, and it's not an issue. And this is how it works. Bruno, come over, and Bruno introduces you to this process. It's very simple, because submodules are a part of Git. So you only clone, you enter the repository, and you just create a submodule, right? That's simple. And from now on, anything that you do with submodules just need to remember to be recursive. So once you introduce a submodule into project, your colleagues will just need to clone recursively and pull recursively. And that's simple enough, because Bruno already introduced to the team a set of aliases for Git. So all of you can work with Git as you did, at the same time leveraging submodules. But not all of the team have introduced the aliases to their configs, so that's for later. And Bruno shows you how to work with that, and that's quite simple, because if you want to make a change to library, it is in your project, in a subdirectory, so you enter, you there commit your changes, and you push them, and right there and then, you can also already go up to your main project, commit and push your changes, and this is already available for all the team. And all that's left to do is to pull recursively. And everyone can use the newest, shiniest version of the dependency. But here's the thing. Let's play, find the difference. Take a look, take a close look. That's what Bruno introduced you to. But 2 weeks later, 3 weeks later, you forgot what he told you exactly, so you come back to the project and you do that. You go into library, you commit, you go up, you commit your changes, you push, and everyone else in the project has the newest, shiniest version of this microservice, and they pull. What changed? Yeah, that's a fun one. Because for starters, Nobody will see any changes because they didn't pull recursively, but this is destructive. Because you made changes on your machine, you went up, and Git doesn't know anything about origin at this point. Submodules will happily allow you to create a reference to a commit that is only available on your machine. So yeah, it will break. On every other developer machine, this won't work until you go back and you push this library to origin. And yeah, at this point, Bruno says that, yeah, this happens over and over. I know. And there are better alternatives, because for most of the technologies, we can manage dependencies other ways. If we even want to track a development branch, we can. For Python, for Ruby, for Terraform even, you can define a dependency not as a release, but as a reference to Git somewhere with a branch reference. So you are able, during development, to track feature branches as for your dependencies, and then only during the release, again, fix them as released versions. But we still use that for most of our microservices, says Bill, and you will have to bear with that for some time. And as you leave, Bruno Olin says, but submodules have better uses. And we'll come back to that. The next thing that Bill introduces you to is a huge project. You know what? We forked an open source project at some point. It has thousands of commits. The repository is like, I don't know, 6 gigabytes. And we forked it like 12 years ago. It is not hosted on GitHub. It is hosted on our on-premise server, and it doesn't really handle the size of this repository well. So once you clone, you should leave your laptop at the company for the night and come back tomorrow. But you see, right now you're not joining the team. We'd only like you to make a small change in this project. And there's a trick for that. Have you seen what we do in CI for builds? We do shallow clones so that we only get a single commit locally. We don't pull the full history from Git. And it turns out that you can clone with a specific branch, or you can fetch any other branch from origin repository, and locally they will be detached entities without any history, but you will be able to work on them. And interestingly enough, you can work with them to make changes, commit your changes, and even push back to the repository, because the commit hash exists in origin, so Git knows where you want to push your changes onto. You can even merge if you do it right, because you don't have any history, so Git doesn't know how to merge feature into main, but you can get more. You can tell Git, you know what, fetch me more commits from the history, enrich my local history so that they are connected somehow until you get the root commit, the place where the branch diverted. And once you have that, you have enough information to merge and to push. And Bill says, yeah, I know it's not perfect, but for this use case, where you only joined this project today, it might work, and it's probably better than cloning for 12 hours. And just for future reference, if you're ever traveling and you're asked to work on a new project, and you're at the airport, and you want to conserve your data plan, that's the way to go, probably. Now, let's review what happened. When we do a full clone, we get everything. We get commit metadata, we get tree information, and we get blobs, the file contents. What we did with shallow clone was that we get none of these and only a full workspace for current commit. And this doesn't allow you to work with history at all. But you know, there are other ways. You could do that. This way, you get commit metadata, so you are able to run git log and learn what were the commits before. But you won't be able to diff by default, and you won't be able to check logs for files because you don't have any tree information. You don't know which files changed in which commits. Now, with shallow clone, this failed. Do you know what happens when you try to get a diff in this situation? It turns out that Git happily fetches these objects for you. So if we want to diff from here to here, we know where to look. We get this object and this object and this object and all the blobs connected to this commit. And the downside is that we get them one by one. When you clone the full repository, all the objects get packaged, compressed, and sent over to you. If you choose this route, whenever you try to do anything with history, most probably you'll be iterating over every object in a separate request, which is even worse than a single clone. So this doesn't really work unless you have a very specific use case. But this might. This, again, only contains metadata. We only get information about commits, about trees, but no blobs. And again, Git will fetch all the needed objects one by one as needed. But we already have all the information about which files changed when. So what we only fetch are the specific blobs. So when we diff, we only get the files that changed. When we look through history, mostly we're using the tree information and not the blobs from the history. So this might be a good middle ground if you're joining a team and they have a huge repository and you want to take a first look at the project. This kind of a clone should allow you to do a few first steps without downloading all the 7 gigabytes. But as usual, Bill says that, yeah, that's not all. But as you go with Bill to the next project, you turn around and you see that your familiar got buffed up. It gets powerful, it gets more useful. And as you go, Bill introduces you to the next project. Here, the repository is also big, but in another way. You remember our microservices? Well, we have still got only one front-end project. We didn't split it up, and not only that, this is the front-end project. It had PHP in the beginning. Then we migrated to HTML with jQuery. Then we migrated to Angular. Then we changed to React. And this is still the same repository. And throughout these all changes, there were rebrandings. And we always kept our assets in the project. So all our prototypes for graphical changes are all there. And the repository is already 12 gigabytes. And we are constantly getting emails from GitHub to migrate to LFS. And that's what you'll do. And that's simple, because it's not a part of standard Git, but it's easy to install. Then you only initialize it globally. And in the project, you start marking files that should be tracked outside Git, which is simple enough. Just remember to commit your Git attributes, because that's where the information is stored. what should be tracked outside the repository. And from then on, you work as normal. You add a file, you commit, you push, and what landed in the origin? Well, not the binary, for sure. There's only a specification which LFS backend we're using and what identifier this is stored at, and what size it has, but it's only for reference. Now, keeping that in mind, where do the files land, right? We have the Git remote, where we have commit after commit, the blobs that we usually store. Our code is kept in the remote, in the repository. But what we locally have as a binary file, when we push, it gets dereferenced, and only an identifier is only kept in the repository. There is an external storage that acts as a blob storage. You only care about identifiers and the content, and there, the objects are not connected to anything in any way. LFS doesn't version. LFS only stores content, and your repository is still maintaining the information about the hierarchy and the versioning and everything else. From the point of view of LFS, there's only an identifier and an object and the content, and that's it. And migrating an existing repository couldn't be easier because you get LFS migrate command. And you can migrate any kind of file or any file that is above a certain size, or during the current development, you can specify to only migrate your local changes, but excluding anything that is pushed to master. I mean, this is a good idea for current development, but it's not what we need right now, says Bill. Right now, we have a huge repository, and we want to slim it up, so we will change history. We will use this or that. Most probably this, because we know that graphical assets are the pain point in this repository. And you know what happens next? Your familiar learns a new trick. So repeat after me, Dracarys. And then your familiar will happily burn the whole history to the ground, replacing everything with the only version that we care about, which is current version. And I know you're scared, so right now I will teach you how to handle that, because this is destructive on the origin, but still Git works with copies of whole repositories. So you can do a mirror clone first and treat it as a backup. If anything goes wrong, you can always force this back, and it will return to the place where you started. And if you ever want it out from LFS, this should help, because it should, on your local repository, hydrate all the pointers with the content from LFS. Just download all the objects that are stored outside repository, and your local repository will get all the information. So then, for example, you can migrate from one LFS provider to another, because they're not using the same kinds of identifiers. So you can't move binary information from one LFS to the other, but you can fetch all of them and then introduce a new LFS configuration. And here comes Bruno. Because, you know, he said that submodules have better uses. And take a look. Bruno, on his laptop, has a setup for free music backup. He has all of his MP3s stored on his laptop in a directory that's a Git repository, and each subdirectory is a submodule with a separate configuration for LFS. So he leverages all the free tiers in the public cloud that he could. He has an Amazon account. He uses MyWasabi and Backblaze. And interestingly enough, as far as I can tell, Backblaze still allows you to create multiple accounts with multiple emails without any credit card information with free 10 gigabytes forever. So if you wanted to try it out, just create a few accounts and create a backup for free with Git, with submodules. And yeah, Bruno is very proud of that. Last things that are important that you need to learn, says Bill. Because you're now a Git expert, junior employees will come to you with issues. I committed and pushed my credentials to main branch. Help me. And the question to the audience, what do you do? From what? Exactly. First thing, you rotate the credentials. And then, just for future reference, you can clean up the Git history if this is possible, just so the new employees don't see bad practices. And the way to do that, if this happened 10 minutes ago, you can probably reset and push force. But if it happened back a few days ago, for example, most probably you'll need to use filter branch, and this is the way to use it. You define what you want to change by simply specifying a command. On each commit, you will run an arbitrary command that can change a commit, and then it will rebase it onto the previous history. So you can remove files, that's easy. And if you're a bash ninja, you can even change contents of files with, for example, sed, and of any other kind of script that is runnable automatically on each commit. And again, you're already familiar with how to make history changes. So what do you need to do afterwards? Yes, and coordinate with all the team. In a closed source solutions, this is simple. In public repositories, this is not really doable. But yeah, if you can, this is an option. Or if you need someone to disappear. I don't know if you had such an occurrence when somebody slams the door when they exit the company, and all their contributions should be forgotten. You can find their commits, overwrite who committed that, and commit the tree. Apply the changes, commit after commit, forgetting a person. I mean, this is toxic. I've seen it happen. But it also has a real-life application. I myself have forgotten that I have different Git configurations on two machines, and I committed to company repositories with my personal email configured, which wasn't, I mean, it wasn't an issue really, but it wasn't elegant. So I was able to filter my branch and apply the changes automatically for all the commits where I forgot that I have different Git configurations. We all know about it. We mostly know how it works. But outside a few cases, I didn't hear from anyone that they are daily using it. And I don't know why, because it just works, right? We have a good commit, we have a bad commit, and if we have 16,000 of commits, we only need to hop 14 times. So yeah, that's efficient. And we do that, and we do that, and we now know where the issue occurred. And usually, this is advertised as here's where the tests are failing. So you can do it manually, run the test, mark each commit as either good or bad manually. You can do that, or you can do it automatically. And interestingly enough, you can do it with any script. Just remember that the script needs to fail for your current changes and pass for the previous ones. So if you're looking for credentials, you'll find them in the past, which will, no, you won't find them in the past because they didn't leak yet. So you need to succeed in the past and fail in the present. Yet just keep in mind that this script needs to return a failure when needed. And if possible, keep it outside of the repository, because remember, you're checking out previous versions. So either it will disappear if you committed that, or it could be a conflict if there was a file with the same name. So yeah, just keep in mind. There is, Bill says. There is much more. Why commit your files when you can tag them? If there is a file that it's not versioned really, there is only one version that will ever appear, or if it's changed, it is changed to the new one, but you don't care about history, you could do that. You hash it, you don't commit it as a file, you tag the hash, and then you can retrieve it manually using cat file from an object in a Git repository that never appeared in any tree, in any commit. This is a fun one. You're working on a feature. Someone gets to you, you know what, I need you to help me with something else. You stash, you check out, you forget what you did, stash then has issues. I mean, it's a mess. You lose context. But you could check out a branch to a different directory, and the only catch is that it's not really a repository. It's a reference to your main repository, and you have two branches checked out at the same time. It's like magic. And with help from Bill, you learned that your familiar is quite powerful. It's dangerous, and with it, you are too. So I hope that you met your Bill already, or you are a Bill to someone. And if you're a Bruno, come meet me in the corridor later. I would love to learn your stories. This will be available with the slides. Do we still have time for questions?
2 minutes.
Fantastically, as planned.
So do we have any questions? I have one. So there is a question regarding the so if you don't store a file in Git, is there a way you can separate versions of the file? So you have a project file that you don't know nothing, and you need different versions for different phases. So can you version this file?
One thing, can I version a file that is tagged manually? You're asking about this trick at the end.
No, I mean previous one for storage large files.
With large file storage, versioning works still in your repository. So the LFS doesn't keep any information on which version is which, but still in your repository, on each release branch, there will be a separate reference to each of these versions. They all exist at the same time, and from the point of view of LFS, they are just blobs. But from the point of view of your repository, whether you check one branch, release branch, or one tag or the other, you'll get a different version of this file. If they're binary, which is the most common case with LFS, no. But if you need to manually div them outside Git, you can use the work tree trick, where you check out one place in your repository, you check out to another directory, and then you use whatever tool you have for diffing these two files. You will have them both at the same time on your disk. Mm-hmm. But and can you set different diff programs at the same time? I never used that really, because that's what.
Yeah, I did some time ago for like Microsoft Word files because there is a diff program for those.
Mm-hmm. Thank you very much.